Good morning to one and all present here. I am Ramya Devi, working as Assistant Professor in SNS College of Engineering. Today I am going to share a small article regarding data cleaning and normalization. So why do we need a data cleaning and normalization before going for an analytics? So cleaning raw input data is often the most important and time consuming part as a data scientist. Data cleaning is a process of fixing or removing incorrect, corrupted, incorrectly formatted, duplicate or incomplete data within a data set. Why data cleaning is important? When combining multiple data sources, there are many opportunities for data to be duplicated or mislabeled. So data cleaning process is not done, then it's going to skew the results and it will ultimately end up with the wrong decisions. So here, whenever the data is incorrect, outcomes and algorithms are unreliable, even though they may look correct. So there are a lot of different kinds of problems and data that you need to watch out for. One is outliers, missing data, erroneous data, irrelevant data, inconsistent data, and formatting. Outliers. So outliers are those data points that are really far from the rest of your data points. In other words, an outlier is a value or data point that differs substantially from the rest of the data. An outlier is an extremely high or extremely low data point related to the rest of the data points in a data set. They can show up due to errors in data entry or measurement, or just because there is a variation in the population you are looking at and you happen to see one of the more unusual values. Here, so the data cleaning. So here we have missing data. A missing value can signify a number of different things. Perhaps the field was not applicable, the event did not happen, or the data was not available. So erroneous data, wrong data, invalid data that the program cannot process and should not accept. Irrelevant data are those that are not actually needed and don't fit under the context of the problem we are trying to solve. And next is the inconsistent data. Data inconsistency is a situation where there are multiple tables within a database that deal with the same data but may receive it from different inputs. Next is formatting. Data can be inconsistently formatted. Take the example of dates. In the US, we always specify month, day, and then the year, but in other countries, they might do day, month, year. So data normalization. So why do we need a normalization? So normalization is basically a data preparation technique that is frequently used in machine learning. The process of transforming the columns in a data set to the same scale is referred to as normalization. Every data set does not need to be normalized for machine learning. It is only required when the ranges of characteristics are different. Normalization is used to scale the data of an attribute so that it falls in a smaller range, such as minus 1.0 to 1.0 or 0.0 to 1.0. Normalization helps to improve the performance as well as the accuracy of your model better. So it will not affect regression model that much, but it needed for linear discriminant analysis and Gaussian naive Bayes. So here there is a useful when the feature distribution of data does not follow a Gaussian distribution. So normalization techniques in machine learning. Although there are so many feature normalization techniques in machine learning, few of them are most frequently used. These are as follows. Min-max scaling. This technique is also referred to as scaling. The min-max scaling method helps the data set to shift and rescale the values of their attributes so they end up ranging between 0 and 1. Standardization scaling. Standardization scaling is also known as z-score normalization, in which values are centered around the mean with a unit standard deviation, which means the attribute becomes 0 and the resultant distribution has a unit standard deviation. And next technique is helpful for various machine learning algorithms that use distance measures such as KNN, k-means clustering, and principal component analysis. Reasons for outliers in data. Errors during data entry or a faulty measuring device or a natural occurrence of an data. Next is box plots, so which is the method used for detecting outliers. So box plots are a visual method to identify outliers, is one of the many ways to visualize data distribution. Box plots divides the data set into three quartiles. One is 25th percentile, 50th percentile, or 75th percentile. Next is the interquartile range method is used by box plot to highlight outliers. IQR stands for interquartile range, which is the difference between your 75th percentile and 25th percentile. So the IQR method computes lower bound and upper bound to identify outliers. So lower bound Q1 is equal to 1.5 into IQR and Q3 plus 1.5 into IQR. So next is the Z-score method. So the Z-score method is another method for detecting outliers. This method is generally used when a variable distribution looks close to Gaussian. So the Z-score is the number of standard deviation a value of a variable is away from the variable mean. So Z-score can be calculated as mean divided by standard deviation. Thank you.